Today we are starting the third chapter of geography from Ncert book, which is named as Motions of the Earth. So in this chapter basically we are going to learn what are the various types of motions of the earth and what it causes to the various situations on the earth. Okay, so as we read we would try to understand. So as you know that the earth has two types of motion, namely rotation and revolution. So earth has two types of motion, guys. It is rotation and revolution. Now let us read further. Rotation is the movement of the earth on its axis. That means when earth has a movement on its axis, then it will be called as rotation. The movement of earth around the sun in a fixed path or orbit is called revolution. That means when earth has a fixed path, which is also called as orbit, around the sun, then this kind of motion is basically called as revolution. The axis of the earth which is an imaginary line, makes an angle of 66.5 degree with its orbital plane. So basically what happens is earth usually makes an angle of 66.5 degree with its orbital plane. Okay, so the plane formed by the orbit is known as the orbital plane. So that means what was orbital plane? Orbital plane is actually the plane which is formed by the orbit. That means whenever earth is revolving around the sun, the orbit which it is forming and the cross-sectional area which the orbit forms is basically called as orbital plane. So the earth receives light from the sun, as we already know. Due to the spherical shape of the earth, only half of it gets light from the sun at a time. So what basically happens is the sun usually can't give enough light to the earth as because of the spherical shape of the earth. Okay, so the portion facing the sun experiences day while the other half away from the sun experiences night. Means as because the earth is spherical, the side which faces the sun usually is having light and it would get daylight and it would experience daytime, and same thing would happen in an opposite manner. Okay, in the other side, okay, it would be night and it would not receive any sunlight. Okay, so the circle that divides the day from night on the globe is called the circle of illumination. So you can see in the figure over here, clearly it is seen. Okay, the line which divides the earth on the basis of light. Okay, like if you could see, the half of the region of the earth is experiencing light but the other region is not experiencing, and the line at which this separation is visible is called as the circle of illumination. The circle does not coincide with the axis as you see in the figure 3.2. The earth takes about 24 hours to complete one rotation around its axis. So what usually happens is the earth usually takes around 24 hours to complete one rotation around its axis. The period of rotation is known as the earth day. That means this whole period when the earth completes its full rotation is called the earth day. This is the daily motion of earth. So this is basically the daily motion of the earth. Okay, so what happens if the earth did not rotate? So this is the very next question which is asked in the next page. The portion of the earth facing the sun would always experience day. So this is a very obvious answer. That means when the earth would not rotate, the side which is facing the sunlight will always face it and it would always be illuminated and it would always experience day, thus experiencing continuous warmth to the region. So this area would always receive the warmth from the sun. The other half would be in darkness and it would be freezing. So obviously it would be freezing because there would be no sunlight. Life would not have been possible in such extreme conditions. So that means though the side which is receiving sunlight is going to have sunlight in it, but it would not accept any life forms in it, and the side which is not receiving sunlight would not have any life in it. Okay, The second motion of the earth around the sun is in its orbit is called revolution, which you already know, and it takes around 365 and 1/4 day of a that means exactly we could not say that 1 year is exactly 365 days, but it is 365 and 1/4 of a day. So that is the reason why after every 4 years, okay, if you do a little bit maths calculation, what basically happens is one extra day gets added up in the month of February. So because 1/4 of every year, if you multiply it into 4 times, then obviously the one extra day gets formed, and it usually needs to get added in the month of February. So which you already know, children, it is also called as a leap year. Okay, so that is a simple maths, okay, which we could tally. We consider a year as consisting of 365, so that is the reason why we usually ignore the 1/4 of a year, because 1/4 of a day, because it is usually 6 hours, and we usually take it for a sake, but it would make a huge difference. It would make a single day after 4 consecutive years. Okay, so 6 hours saved every year are added to make a day over a span of 4 years, which I've already explained to you. This surplus day is added to the month of February. So the one extra day which is more gets added to the month of February, because it usually has only 28 days. So thus every 4th year February is 29 days instead of 28 days, which I've already discussed, and it is called usually a leap year. Okay, so find out when will be the next leap year. So this is a very simple question. You could put down the answer in the comment section, and if it is right, then you could get a like from my side. Okay, so from the figure 3.3, it is clear that the earth going around the sun is an elliptical orbit. So what usually people think is that whenever earth revolves around the sun, it is usually a spherical shape orbit, but it is not. Actually, it is in a almost shape. It has a almost shape like a you could say like a egg, but it's not exactly like an egg also, but almost like an egg, and those kind of shape is usually called as eclipse. Okay, ellipticals, I mean. Okay, and the shape, and that is the reason why the shape of the earth is usually called the shape of the orbit of the earth is usually called the elliptical shape. Okay, so notice that throughout its orbit the earth is inclined in the same direction. So what usually happens is the earth usually inclines in the same direction. Okay, whenever it is, that means it never changes its inclination though it is revolving around the sun. Okay, so a year is usually divided into summer, winter, spring, autumn seasons. So season change due to the change of position of earth around the sun. So the very simple reason for the seasons to change is because the changing position of the earth around the sun. Okay, so look at figure 3.3. they are saying, so they are asking us to look at figure 3.3. so 3.3 figure is basically over here, if you could see. So yes, so if you may notice, there are different positions of earth around the sun. So if you could see in the topmost position, so that position is basically the autumn position, and if you go on the left hand side, you would see it is you could say winter, and if you see on the bottom side, it would be autumn, and if you would see on the right hand side, it would be the summer position. Okay, so in different season, you might notice the rays falling on the earth is in the different position. Okay, so if you may notice in the summer period, okay, or in the summer season, you could say sun's ray is directly falling on the western hemisphere. Okay, western hemisphere, or you could say at the center of the earth. Okay, and if you would see in the autumn season, okay, so the sun's ray is directly falling on the south pole, and if you see in the winter position, the sun is falling usually on the you could say on the eastern hemisphere, and if you could see in the bottommost position, the sun's ray is falling directly on the northern hemisphere. So exactly you might see, okay, over here the differences of light sun's ray falling on the earth is different in different season basically. Okay, so in here they are saying you will see that on 21st June the northern hemisphere is tilted towards the sun. Obviously the rays of the sun fall directly on the Tropic of Cancer. If you don't know what is Tropic of Cancer, you could watch my first video, okay, the first chapter's video from the playlist. Okay, so as a result, these areas receive more heat. The areas near the poles receive less heat as the rays of the sun are slanted. So obviously that is the main reason. The North Pole is inclined towards the sun, and the places beyond the Arctic experiences continuous daylight for about 6 months. So that is the main thing which happens during this phase. Okay, so since a large portion of the northern hemisphere is getting lit from the sun, it is summer in the regions north of the equator. So that means usually during this phase the northern hemisphere, okay, usually experiences summer. So the longest day and the shortest night at these places occur on 21st of June. So that means the longest day you would experience is on the 21st June. Okay, that means the day becomes longest on the 21st of June. So and it becomes shortest at the short, and the night becomes the shortest. Okay, so at this time in the southern hemisphere all these conditions are reversed. That means whatever is experienced in the northern hemisphere is totally opposite in the southern hemisphere. Okay, that means there is winter season happening in the southern hemisphere when there is summer season in the northern hemisphere. Okay, so these are longer than the days. This position of the earth is called the summer solstice. So that is the main cause over here. Okay, and that means this whole region is actually called this whole position of the earth is called the summer solstice. Okay, so there are basically 4 types of what they say positions of the earth. So that is the reason why we are calling it different in a different name. Okay, so on the 22nd December the Tropic of Capricorn receives direct rays of the sun as the south pole tilts towards it. As the sun's rays fall vertically on the Tropic of Capricorn, a large portion of the southern hemisphere gets lit. Therefore, it is summer in the southern hemisphere with long days and shorter nights. So the reverse happens in the northern hemisphere. That means in winter solstice, which is on 22nd of December, what usually happens is the summer is experienced by the southern hemisphere, and the northern hemisphere experiences, you could say, winter. Okay, so do you know that Christmas is celebrated in Australia in the summer season? Yes, so this we already know. Okay, so already know. If you don't know, that what usually happens is, like, as you know, in India we usually celebrate Christmas in the winter season, but in Australia they celebrate Christmas in the summer season. Okay, so that is the main difference basically, because of this solstice, or the position of the earth around the sun. So on 21st March and September 23rd, direct rays of the sun fall on the equator. So that is the main consequence. At this position neither of the poles are tilted towards the sun, so the whole earth experiences equal days and equal night. This is called an equinox. So what usually happens is, when it is 21st March and 23rd September, the sun's ray is directly falling on the equator, so that the night and days period usually is equal. Okay, and this period is usually called equinox. On 23rd September, it is an autumn season on the north northern hemisphere and spring season in the southern hemisphere, and it is usually opposite in the case of 21st March, okay, when it is spring in the northern hemisphere and autumn in the southern hemisphere. Thus you could find these days that there are days and night and changes in the season because of the rotation and revolution of the earth respectively. So that means in this chapter we have learned what is rotation and what is revolution and what usually this rotation and revolution causes. Okay, so as you know, rotation causes the change in the day and night, and revolution causes change in the season. Okay, and we have also learned that the position of the earth around the sun is the main reason for the seasons to happen. Okay, and whatever season is experienced in the northern hemisphere and in the southern hemisphere is totally different, and even whatever season is experienced in the western and eastern hemisphere is also different, all because of the sun rays falling on the equator, or you could say on the earth. Okay, so that is all about this chapter. I hope you have understood. If you have understood this chapter, please don't forget to give like and also share this video to your friends and family, whoever has to understand about this chapter. Okay, I hope you would like this video. Give a like and also share, and if possible please subscribe to the